Good morning. Welcome to AP Computer Science A. Today we are going to be covering section 2.1, using objects. So at this point, you should have your replit ready and ready to go. Don't forget to write or type in your name. Not write, but type in your name. So my name is David Diaz, but your name should not be David Diaz. Then don't forget to submit once you're done so you guys get full credit. So you want to be coding along with me so you have a better understanding of what's happening. Today, we are going to be covering something essential, very essential in the class, which is how does Java memory works and how it gets allocated. We are going to be talking about how Java has two types of memories. It has a stack and it has the heap memory. But before we actually get to that, we have learned that we have two types of variables. We have your primitive types and we have your class types, or what we also call your reference types. So let's go and start with primitive types. We know that the primitives are integers, doubles, boolean, and then we have the other ones, char, long, float, byte. Uh, but for now, in Java, we just use, or for this class, we're going to be using integer, boolean, double, correct? So let's go and start in on line number 17. I'm going to type in int, and we're going to create a integer type with the variable called num. And we talked about doing it in two different steps, correct? That's how we started. And we started because of this. This is the main reason. So in this case, in this step 17, are we declaring or initializing the variable? Correct. We are declaring the variable. Then we go to initialize it. We're going to say num equal to 5. So in memory, in the stack is going to only hold your primitive types. So the stack is only capable of holding your primitive types, and Java does this for two reasons: for efficiency, and also because the heap is going to hold class types or reference types, and reference types and class types can be much, much larger. So therefore, on line number 17, we are declaring. On line number 18, we are initializing the variable. So what happens on line number 17? When it's declaring the variable, what Java is going to do, if you only have number 17, is going to place its integer into the stack. And do you guys remember how many bits are in an integer? Correct, 32. And on line number 17, say, okay, so you want the name num. Then once it gets to line number 18, so if line number 18 wasn't there, that's all it's done so far. But once you type in line 18, it's going to actually initialize the variable. So now it's going to place a value of 5 in here. If I want to be able to create, let's say, another variable, let's say a double, which is also a primitive type, and let's say pi, we are declaring the variable, and then we are going to initialize, and let's go and place pi will be 3.14. Excellent choice. So on line number 20, what is going to happen is going to get a double, and how many bits are in a double? 64. And on line number 20, you are naming the variable pi, so therefore it's going to name the variable pi. That is on line number 20. Once it gets to line number 21, then it's going to initialize and place 3.14 in here. Now for strings, it's going to work very different. For in string, if you remember, we use uppercase. That should give you a clue if it's uppercase variable, that is a class type or what we call a reference type. And reference type is a keyword. Well, it's an essential word that will give us a little more understanding of what's happening. And just say name. So on line number 23, what's going to happen is going to, because this is a string name and the contents can only be stored in the heap. Once we actually initialize name is equal to Mike, on line number 23, the stack can only hold primitive types. So therefore, it cannot hold a string. What is going to happen is going to place a hashtag. And right now, on line number 23, it's called name. In here is going to be hashtag. Once you go to line 24 and initialize it to be Mike, it's going to hold the string Mike into the heap. And we always start from the bottom up. And now it's going to hold the memory location. So in the heap, it's going to be so huge that it's going to keep a memory location in here. And the memory location will be, for now, we're going to talk about hashtag, which is F, G, H. And we're actually going to be able to print the hashtag location later on in the course, once you go into arrays and array list. And let's go and say 5, 6, 7, 8, 9. So let's go and type in 5 numbers. Therefore, now that it knows where it's located, in the stack, it's going to hold the memory location, so it will be, and it's going to reference it. So that's why that's a keyword. It's going to reference your memory location, and it's going to point to it. Once you go into C++, they're going to be calling them pointers because they're actually pointing them. In Java, we call them reference. We are referencing the location. And that is what happens with non-primitive types, which are class types that are also known as reference type. Now, let's go over what happens if we actually change the value. So now that we have, let's go over to line number 26. And let's say we want number to be, now we bought, let's say it's the number of apples that we bought, and now it's going to be 7. We bought 2 more apples. So now we have a total of 7. Now what happens is that automatically just this value in here gets changed to 7. Easy as that. If we were going to change pi to be 3. Like Diaz, you can change the value of pi. It will be 3.141592. Then what happens is that it actually changes the value in here. It changes it directly in here. So whenever you are modifying the values of primitive types, they automatically get modified. Now, let's say that we want to be able to say, you know, Mike now wants to be named Mikey. So some of you guys will think, well, what's going to happen? How is it going to modify? Some of you guys might think that we actually take a Y and just place it right underneath. But remember, there's no space underneath. There's nothing there. So therefore, that cannot happen. Especially, let's say that before I did this, let's say that I create a variable before this and say string teacher equal to ds. Therefore, before this got created, correct? This got created afterwards. So let me just move this up if I can. And before this got created, we created ds. So therefore, first on line number 20, this gets allocated. This one is going in here in there. And now this is teacher. That is line number 20. And now once you get to line number 20, do I have ds in here? No, I don't have ds. So let's say we are having Diaz, then Diaz gets created, and let me just go and change it. Diaz gets created. And now this points to the memory location. Let's say the memory location for this will be 1, 2, 3, 4, 5. So therefore, in here, it'll be at F1, 2, 3, 4, 5. And there's a pointer that's going to be pointing to it, to the memory location. So that is what happens on line number 20. We create the space. Line number 21, we create the variable in the heap. Then once we come over here, number 26, then we have Mikey. Then Mike, and gets placed in here. So once we get to actually line number 33, and we want to be able to add this is what I was getting to. Why? There's no space in there. And instead of doing that, what Java does is going to create an entire, let me just leave an extra space so we can see it. We are going to create an entire new string, and it's going to place it in memory somewhere else. It doesn't really matter because it's going to point to it. Now, let's say the memory location for this is at G. Then what's going to happen is going to change the memory location of name because it doesn't no longer want Mike, it wants Mikey, and that is going to be on G 2, 3, 4, 5, 6. And now the pointer, the reference is going to be changed to this one here. So that is what happens in Java. Now, what is going to happen to this variable here? What's going to happen to this string here? What happens is that we have something called garbage collector. And when Java knows that you're no longer using that space, therefore it goes in there and takes it out. That's called garbage collection. And Java automatically does it. If you actually are coding in C++, you're going to have to be taking care of that manually, like by code. But in Java, it automatically does it for you. So that is what happens when you are modifying the values. So now let's talk about what happens whenever we are copying the values. So let's go and clean up this bit. Let's go and leave just, we are going to leave the number and the name. Well, actually, I'll just leave the name, and then the number will be 5. We are going to get rid of everything else. So that is what you should have at this point. So therefore, the only thing that we have is number and name. So we have, can get rid of this, can get rid of that. So therefore, we have Mikey, we have the number 5 in this case. So let me go back and change to number 5. Then we have the hashtag. It's going to be pointing to Mike, and Mike was right over here. And then let me just move Mikey out of the way. And the memory location for Mike is F5678. So now that is what we have now. And we do have a pointer, so let's go and add the pointer. That's called in C++. In Java, it's called the reference. So therefore, we're going to reference the variable. So something to keep in mind is that we have holding only the stack will only hold primitive types. The heap is going to be holding what we call class types or reference types. So now let's go and copy the values. So let's go and select, we have int, and let's go and say new num, or let's just go and say age, or num2. We're going to initialize it, and then we're going to declare it. We declare it, and then we're going to initialize it, and we're going to place the value of num. So what happens in here? Once again, we are going to declare it num2. So therefore, we're going to grab a integer, and we're going to place into the memory, into the stack, because integer num2, it's also a primitive type, and we have num2. And now we are going to copy the values from num into num2. So they basically just get copied. So we are going to take this value, and we are going to copy them. If I can manage to do so. Then we are going to copy the values in there. That's what happens. So whenever you have primitive types, you take the values and you copy them directly. Now let's assume that now we are going to copy, we're going to make a new name. So string name2. And now we're going to do the same thing. Name equal name2 equal to name. So now what happens once again? We are going to take an integer, and let me just place as blank. So in this case, it's called name2. And now on line number on line number 26, this is the only thing that happens, correct? Once you get to line number 27, you are going to copy the contents of name into name2. So I'm going to go in here, I'm going to copy the values, and I'm going to paste them in here. So now it's going to be holding the same location, reference location. So it's going to reference exactly the same values or the same memory location. So now that is going to be referencing exactly the same memory location. Correct? So now they both are pointing to the same one. So that is what happens when you are working with primitive types versus the reference types. The stack can only hold items or variables that are primitive. The heap will be holding class types or reference types. And the last thing that we need to cover today, and we're going to actually come back to this on the next few sections once we talk more about strings and how we compare them, but that will be until later on in the chapter. The last thing that we need to talk about is num. So null. So let's say I have a string, and we're going to say name3. We can actually initialize it to null. That means that it's not going to be pointing to anything. So what's going to happen, we are going to, let me just get a new one. I should have new ones ready to go. And it's going to be created. And now the variable name is name3. And now it's not pointing to anything. And that is what we call null. So we do have the variable, we declare it, we initialize it to null, but there's nothing there. If we actually print, and we might want to say, well, what do we want to call null if there's nothing there? If we actually go system the print ln and we say name3, and we run it, it's going to do no. But if we didn't have anything here, if we actually got rid of line number 30, what is going to happen? It's going to give us an error. Because whenever we are declaring a variable within a method, then we must initialize it. We're going to talk about other instances, but not until later on. But for now, every time you have a variable, whether it's a primitive type or a class type or reference type, you must initialize it in order for you to be able to use it. Otherwise, you get an error. In this case, we did initialize it to a value of no, so therefore the value is no. But we'll talk more about that later on. So this is the lesson for today. Please email me if you have any questions, and apologize for the delay. Have a great day.